Today we're going to be talking about a new method called completing the square. So the general procedure for completing the square is that you take half of the b coefficient and you will square it. So the general form that this number in the c spot will always be half of your b value squared. And if I were to factor it, it would be x plus half of your b value. So we're just kind of adding to your bank of different methods that we can use to solve different problems. So you're going to notice that these problems all have an a value of 1. So completing the square will only work if a is 1, and typically it works nicer if your b value is even. So this method does not work for every quadratic, but it works for some. So when you look at these problems, we first have to identify our b value. So for number 1, my b value is -6. So I'm going to pull that off to the side, and I'm going to take half of it, and I'm going to square it. So I'm going to frequently say half it, square it. That's what I'm referring to. So half of -6 is -3. -3 squared is 9. So I'm going to come back to the original problem, and instead of c, I'm going to write 9. And then when you think about factoring, well, the two numbers that multiply to be 9 and add to be -6 would be -3 and -3. So this is going to factor to be x minus 3, the quantity squared. The shortcut, if you will, is that it's always this number. So the half number, when you take half of your b value, will always go right there when you factor it. So number 2, again, we identify our b value, which is 10. I'm going to take half of 10, and I'm going to square it. So I get 5. 5 squared is 25. So I come back here, I'll write x squared plus 10x plus 25. And then this is going to factor to be the quantity of x plus 5 squared. And if you think about it, the two numbers that multiply to be 5 and add to be 10 would be 5 and 5. So number 3 would be an example of a problem that's not the most ideal to use completing this square because your b value is odd. I can still do it though, it just doesn't work out as nicely. So when I go to take half of 5, I can't really cut that in half unless I want to put it as a decimal. So if you'd rather do decimals, you can. I'm just going to leave it as a fraction. So when I square this, I get 25 over 4. So when I come over here, my c value that's going to work would be 25 over 4. Which means this problem is going to factor to be x plus 5 over 2, the quantity squared. So you have 3 practice problems. Go ahead and try those. So now we're going to talk about, well, how can we actually apply this to solving? So this looks like a factoring problem. I have an a, b, and c term. It's equal to 0, so it's in standard form. So I would check to see if it's factorable. So if I do that and I do a times c, we get 3. Well, the problem is when I try to find something that multiplies to be 3, I can't find anything that adds to be a -2 because my only factors are 1 and 3 or -1 and -3. And none of those add to be a -2. So now we're going to kind of follow that 4-step process that you see on the notes. So step 1 says get x squared plus bx by itself. So that means the c value needs to move to the other side. So this is a major difference compared to factoring. Factoring, I always want to equal to 0. For completing the square, I want the first two terms equal by themselves. Notice I left a little space right here because we're going to fill in that c value that I need to calculate. So now I'm going to complete the square. So I'm going to take half of my b value, and I'm going to square it. So I get -1. -1 squared is 1. So I'm going to put that c value in that c spot. Now, because there's an equal sign, if I introduce a +1 on the left side, I got to introduce the +1 on the right side to keep things kind of balanced. Now that I found that +1 on the left side, I can factor that by the trinomial. So the two numbers that multiply to be 1 and add to be -2 would be the -1, which is always your half value. So the left side factors to be x minus 1, the quantity squared. The right side, I'm going to add those two numbers. So -3 plus 1 is -2. And now this turns into the square root method. So if I want to solve, I'm going to take the square root of both sides. to get rid of the squared. On the left side, I'm left with x minus 1. On the right side, I get plus or minus I square root of 2. So notice all the things that we learned in the radical, talking about radicals, still applies. And my last step is to add the 1 over, so I get x equals 1 plus or minus I square root 2. So let's try another one. So again, my a value is positive, my b is even, so this is ideal to use. If I were to subtract that 1 over, again, this problem would not be factorable, so I would not be able to proceed that way. So we're going to attack this with completing the square. So I'm going to take half of my b value, so some scratch work off to the side. I'm going to do negative 6 divided by 2, which is negative 3, and then I'm going to square it. And I'm going to add that 9 to both sides to keep things balanced. Because I found the 9, the two numbers that would make this left side factorable would be negative 3 and negative 3. So the left side factors to be x minus 3, the quantity squared. The right side, when I add 1 plus 9, I will get 10. And now the only way we could solve from here is that we would take the square root to cancel out the squared on the left-hand side. If I try to break down 10, the two numbers that only multiply to be 10 are 2 and 5, and neither one of those are perfect. So this is going to stay the square root of 10, and we use the plus or minus because we introduced a square root. And then my last step would be to add the 3 over, so x equals 3 plus or minus the square root of 10. So again, you have 3 practice problems to try. Just quick conversation that these answers are 2 real solutions. If we go back to the first example that we did, this is 2 complex solutions. And the reason this is complex is because it has an I in the answer. So go ahead and try the 3 practice problems. So now we're going to talk about how else we can use completing the square. So a recall for completing this square is that vertex form looks like this. Y equals a times the quantity of x minus h, the quantity squared, plus k. So we're going to discuss how we can take equations that are in standard form and convert them to vertex form. So the process is very similar. So again, I need to move the c value to the other side. So I will subtract the 22. You're going to notice that you see a y in the problem instead of a number over there. So y minus 22 equals x squared minus 10x. And now I would like to complete the square. So we're going to take half of our b value. So half of negative 10, the quantity squared. I hate that writing. I'm going to change that. So negative 5 squared is 25. So 25 is the number that we are going to introduce to both sides. On the left side, we get y plus 3. And the right side can now factor because I found that number that makes it a perfect square trinomial. So this is going to factor to be x minus 5, the quantity squared. Then to get y by itself, I'm subtracting 3. So notice we will not be taking the square root. The directions don't say solve. The directions say write it in vertex form. So I have now successfully created this equation in vertex form. Just kind of relating some things back to what we did before. So if I asked you what the vertex is, remember vertex form is always opposite of the inside number, same as the outside number. So my vertex would be 5, negative 3. My y-intercept would be your c value from the original equation. So the 22 is your y-intercept. This parabola is going to be opening up, and the reason it's going to be opening up is your a value. So when you look at this first equation, notice there is nothing there. It's implied to be a positive 1. Same thing down here, positive 1. So because it's positive, your parabola would be opening up. One more together. So again, we're going to start by subtracting the 95 to get my first 2 terms by themselves. So I have y minus 95 equals x squared plus 18x. I'm going to take half of my b value and square it. So half of 18 squared will be 9 squared, which will be 81. So 81 is that magic number that I'm adding to both sides. On the left side, I get y minus 14. On the right side, this will factor to be the quantity of x plus 9 squared. And to get y by itself, I'm going to now take that 14 and add it back over so that I have converted this equation to vertex form. So, follow-up question. My vertex is going to be negative 9, 14. So remember opposite same. Your y-intercept is going to be 95. And this parabola, again, is opening up because your a value is positive in both cases. If I wanted you to make a rough sketch, super, super rough because these numbers are ginormous, we're going to say my y-intercept is right there up at 95. I'm going to say that my vertex is at negative 9, 14, which will be like somewhere there. Again, just a very rough estimate. And if I were to reflect that y-intercept over, there would be a rough sketch of this picture. This quadratic would have complex solutions because it's not crossing the x-axis. Real quick, in your practice problems, the second one says y equals x squared plus x plus 6. You're going to change that to be plus 2x for the middle term so that it works out nicer.